Hello, everyone. My name is Leah Ding. I'm a faculty member from the computer science department, and I do research mainly on AI for science, and I'm going to talk about a couple of projects that are sponsored by the National Science Foundation and NASA. So how do we advance trustworthy AI for Earth and environmental research? So those are the observations captured by NASA satellites. And as you may notice or not, so we are having more frequent and severe wildfires across the country and also across the world. And also we are having stronger hurricanes every single year, and we are having longer droughts. So there's a lot of changes and in the environment. And we need better tools to help us predict, detect, and prepare ourselves for those extreme events. Okay? And actually, the opportunity is that the data collected by satellites are exploding in scale. So this figure shows you how much data are collected by NASA alone every single year. Okay? And the NASA's distributed active archive centers alone collect close to 50 terabytes of satellite data every single day. Okay? And we have other satellites observations from other countries like European, like Asia. Okay? And not all of those data are being used. And also for NASA, for example, there are new missions rolling out that will further expand the data volume instead of diversity and resolution, temporal resolution and the geographical resolution. So how do we, for example, utilize or data mine the intelligence from those huge of data? So this is where AI and machine learning comes into play. So we want to build AI for science by turning this data growth into environmental intelligence so that we can transform this huge amount of data to timely, trustworthy, and actionable insights to help people to understand, predict, and respond to the changes in the Earth environment. Okay? So with the environmental intelligence, actually, we can do lots of things. For example, we can understand what are the different environmental conditions and what kind of human activities and the policymakers are impact each other. And we can do different simulations to assess what comes next if we do this or if we do that. And basically, this allows us to build, basically, to understand the environment better so we can prepare better for the future conditions. Okay? And also, basically, machine learning model helps us to do that. And that is only, the data I'm showing you is only the data from the NASA satellites. But if you look at all the sensors we are using to observe our environment, is more than that. So in addition to the spaceborne satellites, we have aircraft observations. We have the observations from the drones, the UAVs, and we have the observations from the ground-based sensor network. So the data is very different from the standard data that we see in computer science. For example, we talk about the standard imagery dataset, which is RGB images. But if you look at images captured by those instruments, for example, if you see the picture over there, right? They use different type of channels, and basically each channel captures different type of information. For example, thermal signal, humidity information, and things like that. So the standard machine learning model built using standard imagery dataset cannot work for the satellite imagery. So that's why we are building customized machine learning model that is able to understand the information captured by those satellites. And on top of that, we want to deploy those machine learning models to the devices. For example, if we have, instead of deploying a large model, if we can have a small model that can be deployed to any of the devices, for example, CubeSat or drones, that may help with the real-time detection as well. So there's a lot of opportunities, and lots of things can be done in this space. Okay, and here I'm showing you, okay, So just show you how many satellites has been launched by NASA actually over the past couple of years. Okay, so based on the satellite observation, we can observe all different type of information about the Earth. We can see the clouds, we can see the ocean, we can see the land uses. Basically, you can see the formation of tropical storms. You can see, for example, how wildfires grow and spread, right? So we have lots of data that needs machine learning model to help us to find intelligence from that, okay? But the challenge is that it's not that easy. Let me show you an example, okay? Let me take the hurricane prediction, for example. This is a hurricane called Otis that was basically landed in Mexico 3 years ago. Okay? And basically, the figure I'm showing you here is the trajectory of the hurricane. So on the horizontal axis is the forecast hour. On the vertical axis, we have the category of the hurricane. Okay, so as you can see, this hurricane escalated from category 1 to category 5 within 24 hours. And those are the forecasting results of all the existing models. None of them ever predicted this hurricane will escalate to category 5 within 24 hours. So we need some better models to help us for the prediction. Okay, so right now we have a couple of ongoing projects sponsored by NASA and the National Science Foundation. So one of the projects is that how do we build AI-based digital twins to allow NASA scientists to better understand the data being collected, like 50 terabytes every day. And also how we study what-if scenarios. How do we predict and track what kind of clouds will be, for example, developed into deep convection and further being developed into tropical cyclones or can be escalated to very damaging hurricanes. And on the other hand, we are also studying, for example, how we can better predict, detect wildfires that are observed by different type of instrument. And when we study this problem, one challenge is that the scientific data, satellite observations are so fragmented in the sense that there's no existing data that can be used directly by machine learning model. So part of our work is curate this data set, create labels with expert in the loops. So this data set can be open sourced, can be leveraged by other people working in the AI field, so they can build better models. And also, basically, this is also a cross-institutional effort. So we have collaborators, computer scientists from College Park, and basically we have scientists from NASA that helps us to curate that data set that will be open sourced to the community. Okay, that concludes my talk. Any questions?
Earlier today, we talked a lot about hallucinations. What do you do to kind of make sure that these predictions of hurricanes and wildfires are not hallucinated?
That's a good question, because one problem we are dealing with is the hallucinated hurricane, for example, or hallucinated wildfires. So right now, what we're developing is that in addition to machine learning model prediction, what we are generating is the uncertainty estimation. For example, if the AI model tells you the wildfire will spread to this and that area, in addition to that, we let model tell us how certain or how uncertain you are. If the model tells you, hey, the wildfire will be spreaded to, for example, this area, but I'm so uncertain about it, then basically that helps us to do some quality control of the AI prediction models.
Thank you. That was very interesting, very practical. 2 questions. Are you being impacted by cuts to NASA and National Science Foundation for your research grants? And secondly, what you just talked about, have you learned anything with respect to predictions for that Otis hurricane that you referred to? Why was that not predicted, and what is needed to help predict these outliers?
Okay, thank you for the question. So first of all, luckily, my funding didn't get cut because of the changes from the federal agencies. I really appreciate that. But I do know some of the faculty members, their grant got impacted. Second, to your question, so one challenge of machine learning model is that the extreme cases, for example, fast escalation of a hurricane from category 1 to category 5 within 24 hours, those are the rare cases in the training data set. So the model is bad at predicting those outliers or the unseen scenarios. So that's why one important part of our research is let's quantify the uncertainty of machine learning models. It doesn't know. It should tell us it doesn't know. It's not sure. Then we can use other type of not AI dependent approaches to make better prediction. So, but it's hard even for human to recognize what you don't know if you don't know. So the uncertainty quantification of machine learning model prediction is still a challenging problem, and we are working on that.
Thank you so much.
Thank you.